All right, hey, it's your old pal, Mr. Cook. Let's go through these ones. What do we got? Find the vector, find the magnitude, and then find the dot product and the angle between. Okay, so we just got to use a little bit of trig, I guess, in this stuff. So find the magnitude. Let's do that part. We've already practiced that with number 4. So magnitude is going to be just like the Pythagorean theorem, essentially. So magnitude of the vector 6, comma 8 is going to be equal to square root of 6 squared plus 8 squared. So that's square root of 36 and 64 is 100. So 10. 10 would be our answer for this one. The magnitude, by the way, is always going to be positive. It's never a negative number, no matter what. All right, then the direction. So for direction, think about remember when I talked about what the vector looks like? It can look like a right triangle. So imagine going over 6 and then up 8. Okay, it goes like this, right? And then 6 and 8 represent the components. So imagine that this side length is 6, this side length is 8. What we're looking for is this angle theta, to figure out the direction that it goes. It always starts at 0 degrees. So how would we find that if we knew 6 and 8? Well, 6 is the adjacent side, 8 is the opposite side. So we're going to use tangent for this. So the tangent of theta is equal to opposite over adjacent. So if we want to find theta by itself, we'd undo the tangent. In other words, we'd take tangent inverse of both sides. And you'd probably want to keep your calculator in degree mode for this one. And you just round it to 3 or 4 decimal places. Probably should be a good value for that. So let's do that. Let's see, mode, degree mode, and then tangent inverse of 8 over 6. Round to 3 decimal places, 53.130. There you go. And you're just going to keep doing this kind of over and over again. You can fast track it if you want, because you're just going to continually use tangent. So you really don't need this graph. You just need to remember that it's opposite over adjacent. And on the graph, that translated to the y part over the x part. Okay, so here we go. That's basically what we're going to do over and over and over again. All right, the magnitude of 1, 1. So magnitude of the vector, I guess I call it v. So we'll just use that letter, is equal to the square root of the components squared. So 1 and 1 is 2. So square root of 2 is our magnitude. And then the tangent, remember it's the y value over the x value. So in this case, it's 1, which is the y value, over the x value, 1. And I don't need my calculator for this. The tangent inverse of 1 is going to be 45 degrees. Because I know my unit circle, right? Okay, there you go. There's letter B. All right, and then letter C, the magnitude of the vector V is equal to the square root of 5 squared plus 12 squared. So that's a 5, 12, 13 triangle. So 13 would be the side length. And then the angle theta is going to be equal to tangent inverse of, those two numbers. So it would be the y value over the x value. Let's see what that's going to be on my old calculator here. Tangent inverse of 12 over 5. 67.380 degrees. There we go. Okay, last one, the letter D. So magnitude for this one, V. What do we got here? So that's going to be square root of -3 squared, 9, plus -4 squared, 16. So 3, 4, 5 triangle. So the magnitude, it's always positive, is going to be 5. And then, so this is going to be a little bit tricky, but because we've got to use, some of the rules of inverse trig functions to find this angle measurement. So let's see here. We got a tangent inverse of -4, the y value, over the x value, -3. And let's see what that's going to be equal to. This isn't going to give us the angle that we're looking for, by the way. It's going to be a little bit off, and I'll show you why in a second. So tangent inverse of -4? Yeah, over -3. All right, so they give us 53.13, which is the same number that we got in letter A, but this is actually wrong. Here's why, okay? If I did graph out the, this vector, I'd start at 0, 0, then I go to the left by 3, and then down by 4, like over here. And what it's asking for when it wants to find like the angle measurement is the angle, like what the angle measurement is from a 0 reference. So it starts at 0 and makes its way all the way to here. This is not 53 degrees. 53 degrees would be like the opposite of it, like right here. This would be 53 degrees, 53.130. So what we need to do is like add on another 180 degrees to get to the actual angle measurement. So the actual angle measurement is going to be 180 plus 53.130, which would be, let's see here, 233.130 degrees. And, you just need to be cognizant of like what quadrant this is in. This is in quadrant number 3. So obviously it's going to be some angle measurement between 90 and 270. So 233.13 is the one that we would use there. Okay, a couple more questions. So find the vector v with a given magnitude and direction. Yeah, okay, so let's see here. Direction is 0, magnitude of 5. If I just draw that out, it's pretty obvious. If it's a direction of 0 degrees, it's just along the x-axis. That's 0 degrees. And if it goes out 5, then if it starts at the origin 0, 0 and goes out to 5, then that means that it just goes to the right by 5 and up by 0. So 5, 0 would be my magnet or my vector. Here's how you can fast track it. There's actually an equation for this, and it has to do with your your beloved unit circle. Okay, here's how it goes. So you can always write it up like this. If you know the magnitude and you know the direction, you just go the magnitude of the vector, whatever it is, v, magnitude of v, and then times the cosine of the angle theta. Remember like cosine is x, remember on your unit circle, same thing here. And then the magnitude of v times the sine of theta will give you the y component of this vector, okay? And that'll work every single time. So yeah, I mean, you can just kind of start it off that way. Magnitude 5, direction 90. So that's going to be, let's see here, 5 times the cosine of 90, which would be 0. And then 5 times the sine of 90, which would be 1. So this is going to turn into 5 times 0, which is 0. And then 5 times 1, which is 5. So 0, 5 should get it done. Magnitude of 2, direction of 60 degrees. So it'd be 2 times the cosine of 60. Cosine of 60 is a half, right? Yeah. And then 2 times the sine of 60. That'd be square root of 3 over 2. So I think it should be like 2 times a half, which is 1. And then 2 times the square root of 3 over 2, which would be square root of 3. So it looks like we got 1 and then square root of 3. That would be how it would look at the very end. Okay, a little bit more. Magnitude of 3 square root of 2, so that'd be like 3 square root of 2, and then direction of 150, so cosine of 150. And then 3 square root of 2, sine of 150. All right, so think about like where, 150 degrees would be, right? It's like on our unit circle, 150 would be like over here, right? It's like in quadrant number 2. So that's where like the x value would be negative, and then the y value would be positive. So just keep that in mind when you have your values. Make sure that the sign goes on, the sign SIGN goes on the right value, okay? Because sometimes it can be kind of duplicitous, like if you're in the 3rd quadrant, for example. Okay, so then I just use my calculator for this. Wait, no, I don't need that. I know my unit circle. So let's see, cosine of 150, that's square root of 3 over 2. So this is 3 square root of 2 times square root of 3 over 2. Right? Isn't that right? yeah, and then it's negative because it's in the second quadrant. And then let's see here. Sine of 150 degrees is a half. So that'd be 3 square root of 2 times 1/2. So what will we end up with here? Gosh, let's see here. Looks like negative 3 square root of 6 over 2. And then 3 square root of 2 over 2. So I'm thinking that's what the answer is to that one. Right? Let's see. Direction 150. Sine is a half. Cosine is negative square root of 3 over 2. Yeah, that's right. Okay, so there you go. There's D. Let's see. E is the magnitude of 12, and then theta is 210. So 210 is in quadrant number 3. So I just got to remember that, like, I'm going to have a negative x and a negative y for my vector. Okay, so I've got a magnitude of 12, and then cosine of 210, and then a magnitude of 12 and a sine of 210. All right, let's see what we got here. So that's going to be, let's see, cosine of 210 is, that's 30 degrees past 180. So that'd be reference angle of 30. So it's going to be, cosine is negative square root of 3 over 2. And then 12, and then sine is negative a half. So times negative a half. And then let's see, so that's going to be 12 over 2 is 6, so it's negative 6 square root of 3. And then negative a half times 12 is a positive 6. So there's our component for that one. Oops, so that should be a negative 6. Sorry about that. All right, next up, a magnitude of 50, and then angle measurement 280. 280 is not a unit circle value. So here's what I'm going to do. I'm just going to leave it like this. So it's like 50 times the cosine of 280, and then 50 times the sine of 280. And, you know, at that point, there's not a lot you can really do with it. You can, like, plug it into your calculator or whatever. 280 is in the fourth quadrant, so you should have like a negative value for sine and then a positive value for the x value for the cosine. Okay, 7. So if u equals that, v equals that, and w equals that, find the following. So this is what we call the dot product. The dot product is what happens when you, like, take the you take each of the corresponding components, you multiply them together, and then you add them up at the end. Okay, so, like, here's how it would look. If I were to take u dot v, it would be 2 comma 2 dot negative 3 comma 4. And here's how you do dot product. Ready? It's just, you take 2 times negative 3, and then plus, and then it's going to be 2 times 4. What we get is, instead of a vector, which is something with magnitude and direction, we just get a value with magnitude, which is called a scalar. So we're just going to get a scalar value from this. 2 times negative 3 is negative 6, and then 2 times 4 is 8. So if we add those together, we just get 2. 2 is our dot product of u and v. All right, now this should also have a dot, like, in between the parentheses and the w there. So it should be written up like this: u dot v dot w. And then it'll make sense. Or no, actually, no, it doesn't need the dot there. My bad, because this is just going to be a scalar multiplication on there. Geez, I almost made a mistake there. Sorry about that. So you do your dot product first, just like, with order of operations, do the stuff in the parentheses first. And then we're just going to multiply that on w. So we already ended up doing u dot v. We got 2. So this turns into 2 times w, the vector. And so that's going to be 2 times w, which is 1 negative 4. So what do we get there? If we just distribute that in, that's 2 comma negative 8. So there's our answer for that one. And how did I get 2? Well, remember, I did this work like just a second ago. It's the same thing. Okay, next up, C. So let's give ourselves some room here. So we've got the u vector, which is 2, 2. And then dot 2 times the w vector, which is 1, negative 4. We're going to distribute that 2 in first. So that becomes a 2 and a negative 8. And now we do the dot product. So it's going to be 2 times 2 plus, and then it's going to be 2 times negative 8. All right, so we've got 4 minus 16. So that's going to be a negative 12. So negative 12 is what we would get for our answer for C. So like in this one, we still had a vector. In this one, we have a scalar. And in this one, we have a scalar as well, just like regular old values for those. Then last one, D, find the angle between these two vectors. Oh, crap. How do you do that one again? I think it's like the magnitude of U times the magnitude of V. And then it's like times the vector in between them. Or no, times the angle between them. It's going to be the cross product. Let's see, angle between the two vectors. I know there's a formula for this. Sorry, I don't have it just memorized out the top of my head. Let me get my phone out. I'll just Google it, and I'll show you how to do it. All right. Angle between two vectors. There we go. Oh, yeah, it is just cosine. Okay. Oh, that's embarrassing. So it is just the dot product is equal to the cosine. Okay, so like you started off with the dot product formula, and then that's equal to the magnitude of the two different vectors multiplied together, because those will just be like scalar values, right? And then times the cosine of the angle between them. So what we're looking for is that angle. So here's how we get it. We take, we find the dot product, we find the scalars, and then we just solve for theta. So if you wanted to solve for theta, here's how it would be. Like, the magnitude of U and the magnitude of V are just numbers, so I can divide those out. So here's what I get. I get U dot V over the magnitude of those two vectors multiplied together. That's equal to the cosine of theta. And then how do I get theta all by itself? I just, undo the cosine. So I cosine inverse both sides. And that just gets me my theta all by itself. Okay, so this is just like, a formula, basically. So let's do it. Ready? So theta is going to be equal to cosine inverse of, I got to do the dot product of U and V. And I think I already did that, right? Yeah, I did the dot product over here. So it's like 2. So 2 over, and then what's the magnitude of U? Let's do that one real quick. So magnitude of U is equal to the square root of 2 squared plus 2 squared. So that's 4 plus 4 is 8. So square root of 8 times the square root of V. Let's find out what the magnitude of V. Let's see what the magnitude of V is. Let's see. So it's negative 3 squared plus 4 squared square root. That should just be 5. 3, 4, 5 triangle. So 5. Okay, and then we type that into our calculator, and that'll give us the angle between those two. So let's see here. Cosine inverse 2 divided by parentheses square root of 8 times 5. Okay. All right, there's the angle between those two vectors. It's going to be 81.870 degrees. All right, there you go. So there's number 7. I'll wrap it up with the last video going over the word problems. All right, see you then. Bye-bye.